Light is the source of life. And how do we sense the light? Sometimes like with our eyes, but sometimes by using sensors. So it is time to explore the light sensor. So let's have a look at the circuit and the module. As you can see, it has two modes, again, one switch and another dimmer, which adjusts the sensitivity of the light sensor here. And this light sensor actually called light dependent resistor. So it is basically a resistor, and I will try to show it to you in here. And as you can see, it is a resistor, and when light hits on top of this resistor, the resistivity of that module changes, and the light sensor reads it and sends signal accordingly. So basically it detects the amount of light, and you can change the sensitivity with dimmer. When the sensitivity increases, it can detect even fainter lights, small lights, right? And it sends signals when there is light if you are using the module in mode A, and if you switch it to mode B, it sends signals when it is dark. It is always to explore and learn. It's always more effective to learn by trying. And let's use the light sensor here along with USB power. And as you can see right now, it is in mode B, and I need to make it darker in order bar graph to turn on. And as you can see, I can see two lights. So even though it is dark, right, it's still not turned on. Five lights is not turned on because the sensitivity is at maximum. So it even detects the light coming from under my hand, right? So even though I close every part, you can see it still sees some light from the cracks of my hand. And what you need to do is you can decrease the sensitivity. Let's put the sensitivity in the middle. And right now we will see more lights as I close. You see? Oh. And one actually mistake that children do, and I did it in the first time as well. I closed my closed on top of the LDR, light dependent resistor, with my hand. And as you can see, it still is not in full dark because even light can pass through my finger. So we need to put it in the shadow, complete shadow, in order to make it work. And if I switch the mode to mode A, and if I close now, as you can see, number of LEDs is turned off, decreases. You can also explore this along with counter. So I see 5 volts in counter and 5 LEDs. And as I make it darker, number of LEDs decreases and the voltage drops to 0 volt. And in real life, we have these LDRs, light-dependent resistors, in different places. For example, in street lights. So it is not logical to control the street lights with remote control or a button. You can just simply use an LDR, and when the light around you decreases, street lights can open automatically. LDRs are being used for solar trackers as well. For example, if you are using a solar energy panel and if you want to track the sun along the day, LDR are being used to spot the position of the sun and adjust their position accordingly. So what they do is they sense the amount of light coming from different places. They just turn around, look at the sun, and they find the maximum sunlight when they are facing towards sun, and then they send the position data to motors to run and position the solar energy panel accordingly. So one weird fact, actually, I can make this a little bit closer, smaller, and Willoughby Smith discovered these photoresistors in 1873 when he was working at a company that installed telegram wires, telegram. So he was responsible for inventing an instrument, a tool, to detect the electric leakages in underwater cables. He mainly focused on working with the element selenium. This is important. And during his studies, something unexpected happened. These unexpected things sometimes can lead to new inventions. And he realized that the semiconducting element, selenium, allowed electricity to flow when it came in contact with light. So selenium is a very important element, not only for light-dependent resistors, but for other usages. Because when selenium comes in contact with light, the electricity starts to flow. Today, all modern photoresistors are developed as a result of Mr. Smith's unexpected discovery. Thank you for watching. See you in another bit.